Awesome. I think we're doing this right. Okay. Doop, doop, doop. Okay. Let's move this over here so it's out of my way. Okay, so here we go. So let's go over, we did A and B. Let's do this A and B. Let's do actually this one right here. Quick review. So we have an ordered pair. It's not one of our special ordered pairs. It's just an ordered pair. And if we graph where this ordered pair is, negative 10, 0 would be over here. And so the angle that negative 10, 0 would be associated with, it's not the special ordered pair for the angle, but it is an ordered pair that goes with the angle of pi radians or 180 degrees. Okay. So if you've memorized some extra values for your quadrantals, like sines and cosines and things, you might be able to shortcut answering this problem. If you haven't, no worries, because anytime we have an x and a y, meaning right here, an x and a y, all we need is r, and we can write trig ratios. And x squared plus y squared always equals r squared. When it's a special ordered pair, r is going to be 1 automatically, but this relationship will still be true. So if you're not sure if you should be using 1 for r or not, double check it this way. Do x squared plus y squared and solve, get r squared, solve for r. If it's supposed to be 1, you'll get 1. In this case, negative 10 squared plus 0 squared equals r squared. So 100 plus 0 equals r squared. So 100 equals r squared. And so automatically, because r is always positive, my r is going to be 10. So little note to write here, and I have extra space to write it. If you need to write it again, r is always going to be positive in our x, y, r setups. And so then I just write my ratios. Y over r, which is 0 over 10 in this problem, which is 0. Sine of 180 or sine of pi, always going to be 0. Cosine is x over r, negative 10 over 10, which is negative 1. Cosine at 180 or pi, always going to be negative 1. Tangent, y over x, 0 over negative 10, which is 0. Tangents are actually related to slopes. So if you think about, if you're on the x-axis, you're on the horizontal axis, your slope is 0. Your tangents are going to be 0 if you're on this axis. If you're somewhere on this axis, like at 90 or 270, your slope is undefined. That's a vertical axis. Vertical line has an undefined slope. Angles on the vertical have undefined tangents. So 0 tangent right here, 0 tangent if you're an angle right here. I'm tapping with nothing. 0 tangent, 0 slope, 0 tangent, 0 slope. Horizontal has a 0 slope. Vertical, undefined slope, undefined tangents. Or you just have to remember 0 in the numerator makes a 0 when you write the ratio. Flip over this. So 10 over 0 becomes undefined for cosecant. Negative 1 reciprocal is just negative 1. That's nice. And same thing, 0 or negative 10 over 0 becomes undefined. Now, I know everybody can do that. Everybody is 100% keepable. I'm not going to give you like Jagunda numbers to deal with X and Y to try to like mess you up on figuring out R. Some cases R is going to be a root, and that's cool. We'll just leave those roots. What you have to make sure you study is the process. I have X and Y. I use this to find R, basically Pythagorean theorem. Even though in some of these cases you can't really make a triangle, like the quadrantals are weird like that. You can't really make a triangle with like a zero side. But it is a Pythagorean relationship. And then having these guys memorized and then knowing that these are the reciprocals. So hopefully the two that you did on the little Schoology homework just kind of refresh this in your memory. This is definitely one of the things, since we're not quizzing on this before the test, this would be extra to make sure you study. All right. We're going to actually skip a little bit to, these are good. These are good. This page is pretty much all about ASTC. So we're going to flip to this page. So go ahead and flip. This is all the way on the very back. I got a bunch of these here. We're not going to do necessarily all of them, but this is another version of an XYR question. Okay. So the easiest kind of XYR question is, I give you X and Y, you figure out R, you build the ratios, you're done. So that's kind of what we did on that previous page. We had ordered pairs, X, Y, we figured out R, we wrote all our ratios, and we were done. In this kind of problem, first thing you'll notice, you're given a ratio. Tangent, and I have some different Greek letters on here. Don't let them mess you up. We use Greek letters all the time to represent angles. This is actually a Greek, the lowercase a in the Greek alphabet. Okay, so it's like a little alpha. Looks like a little squiggly thing there. So we have two pieces of information here. We first of all have that the tangent of our angle, where am I going with my pens today? That stuff. Okay, so the tangent of my angle is 5/3, and I know my angle is over in quadrant 1. Now, there's a couple different ways you can do this problem. Okay. One of the things that might help you when you're doing this problem is to draw a little picture of the angle we're talking about. So if we're talking about a quadrant 1 angle, that would mean I'd be looking at something like this, or a triangle like this, and I know that would have to be the ordered pair. Some XY combo, where X and Y are both positive, and I'm going to write little positives by them, because I'm talking about a quadrant 1 situation. Now, before I try to put any other pieces together to figure out other information about the ratios, I'm going to take the one they gave me and I'm going to fill it in. Well, thank you. I'll take one. Tangent is 5/3. Okay. And automatically, without even blinking, I'm going to make the reciprocal of that and go, oh, 3/5 for cotangent. And I'm a third of the way to my answering this question. Now I just have to figure out extra information, And then that way I can create the sine, and then once I have the sine, I can write a cosecant, and I can write a cosine, and once I write a cosine, I can write a secant. So, here's one way to think about this. Tangent is y over x. So when I see that my tangent of the angle is 5 over 3, and I'm in quadrant 1, that must mean this ordered pair must have been 3, 5. How is that? Okay. Or something that's related to 3, 5. If the tangent came out this way, okay, that's all right, and the tangent is y over x, then one way to get a 5 over a 3 is for y to be a 5 and x to be a 3. So I'm just going to, that's the easiest explanation, so that's the one I'm going to go with. Okay. Other ordered pairs that would have the same result, like 10 over 6, will still give me the same ultimate answers for, so as long as I find one reasonable combination that works, I'm in good shape. All right. That part is super important because notice now that I have this filled out, I can finish this problem. Chloe. You mean when you're looking at the ordered pair?
Yeah.
Okay, that's a good question. When you're looking at the ordered pair, if it's, one of the ways you'll know is you'll recognize it as kind of one of like our special ordered pairs. We only really have a couple combinations. We have this one, we have this one, we have this one, right? With different combinations of pluses and minuses. So these are the special ones with r equal to 1. Okay. Now, and then everything else doesn't. But let's pretend for a minute you're looking at this going, is that special? Is that not special? I don't know. Well, this is always true. Okay. So if I do that, it's not going to be fun, but it'll be all right. We can do it. If I say, all right, well, let me check. Square root of 3 over 2 becomes squared, becomes a 3 over a 4. You okay with that? Okay. And 1/2 squared becomes 1 over 4, which is 4 over 4, which is 1. So yeah, so this is the special one with r equal to 1. So that means that's cosine sine.
So will it not tell us, like, on the test, like, if it's going to be the one with the R or not?
If I'm going to give you a problem that I want you to do with this kind of technique, then the ordered pair I give you, I purposefully will not give you a special one. So if I give you this and I say, okay, find these guys, just go with the understanding, okay, I need to figure out R. And if for some weird case this happened to be the special one, you would get that R is 1. And so you would end up answering these the exact same way by putting y over r, x over r, and so on. Okay? Usually if we're talking about a special scenario, it's more of a type where I'm like, hey, take this angle and tell me its sine and cosine, like 60 degrees or pi over 4 or 5 pi over 3, versus this is like, hey, I have some mystery angle and I'm just telling you what this is. Find me other things about the angle. Okay. when we do the test review, Chloe, hopefully you'll be able to see kind of like different problems, and so that'll make you feel. I know I understand that you're a little concerned, but I promise you, it'll be a little bit clearer. I think you'll see just the different styles of problems. Okay. So here we are. Stuck. Broken. No. Okay. This seems a little touchy this morning. All right. So y and x are 3 and 5. So 3 squared plus 5 squared equal r squared. So that's 9, and that's 25. So r squared is 34. So r is square root of 34. Which is ugly, but that's okay, because everything doesn't have to be beautiful to be right. I can use that. I'm okay with us leaving it in the denominator. So when I write my sign and I write 5 over root 34, that's fine with me. Sure, why not? And cosecant then is root 34 over 5. If you want to rationalize, if you want to write that sign as 5 times the root 34 all divided by 34, you can do that. Or you can just leave it. I'm basically on team leave it. 3 over root 34. Because all I'm doing is putting x over r. And then flip it for the secant. All right, so they're kind of the same problem. It's still an XYR problem. However, it's kind of like you're given the information a little bit more coded. It's not like, oh, here's the ordered pair, just do the work. It's, oh, here's some information. And from that information, we've got to figure out what the ordered pair is going to look like, and then we can build the answers. The biggest tricky part in doing the problem this way is watching for the positives and the negatives. Okay. Let's go down to problem 14 next, because that's a good problem to show that. The positives and negatives part is what you're going to have to get from the information about the quadrant. That's why the quadrant is there. Your quadrant of there is so you can think about positives and negatives. So if I'm over here in quadrant 2, like this problem says, and I'm rotating over to an angle in quadrant 2, and I have an ordered pair on this angle in quadrant 2, when I write the ordered pair in quadrant 2, my x is negative and my y is positive. That's not a trig thing. That's just an ordered pair coordinate plane. That's an algebra 1 thing. If you're in quadrant 2, you go to the left and then you go up. You have negative x's and positive y's. This fraction they gave me is the sine. Sine is y over r. So when I write my relationship between x, y, and r, I got to make sure that I'm using these numbers the right way. This is a y and an r. How do I know that's a y and an r? Because it's a sign, right? Signs are y and r. Because this said sign, that I knew those were y and r, just like because this one was tangent, and tangent is y over x, I knew that one was y and x. So if I know what y and r are, I have to figure out x. X squared plus 4 squared equals 5 squared. And a lot of you will look at that and go, oh yeah, that's that special one. That's everybody's favorite Pythagorean triple. 3, 4, 5. But if you don't recognize it, you go through the arithmetic and you get x squared is 9. So x technically is plus and minus 3 in the algebra world. But because of our trig problem we're doing, I need to use -3 for x. When I'm figuring out x or y, I've got to figure out whether they're positive or negative, and that's going to be based on what quadrant you're in. I'm over in quadrant 2, my x has to be negative. So my cosine is -3/5. My tangent technically is 4/-3, even though I like the negative better up top. My cosecant, that's the buy one, get one. They gave me the 4/5 for sine, so I know cosecant is 5/4. My secant is 5/-3, even though I would like to float the negative up to the top. And my cotangent is 3/4. -3/4. I don't think I said negative. I personally would prefer to write those tangents with the negatives up in the numerator. That's just a little nicer mathematically, but if you leave the negative kind of stuck to the number, that's okay. We're going to find out, though, in some of these problems, we may not see that negative where it's supposed to, on the number it's attached to. We may see it having floated to the top, and we'll have to think about who has to be negative to make a certain problem work. All right. So, figure out what ratio you have. X squared plus y squared equals r squared. Use that to find the missing number. Make sure you put positive or negative on the missing number to match the ordered pair. If the missing numbers are, it's automatically positive, so that one's easy. And then based on the ordered pair and the r, and in this case, r was 5, we build our ratios. Definitely more room for error on these problems because you've got to think about more things and how they work together. You should expect a couple of each of these on your test. Not tons of them, you know, I can't give you a whole test with nothing but these guys, but figure at least once, maybe twice, you'll have to do something like this. Once, maybe twice, you'll have to do something like the ordered pair version. All right, so see if you can do number 13 yourself. And then we'll do one more of this type. And then we'll be ready to head for the finish line, just thinking about ASTC. But right now, try number 13. Find all the rest of the trig ratios. If the cosine of my angle is 7/10, and I'm in quadrant 4. So 2 pieces of information you need there. You have the cosine, and you know you're in quadrant 4. Okay. Let's see what this says. Yeah, my pass is up front. Oops. Go over here. Let's cut this. So these are a couple notes I would write for myself as I started to solve this problem. First thing I would do is I'd draw a picture about being in quadrant 4. And then when I drew that picture, I would think about my ordered pair relative to that quadrant, and I would write that down. And so I know quadrant 4, positive x, negative y. I go to the right, which is positive, and then down to get to an ordered pair in quadrant 4. Second thing I would do is I would label these guys for myself. And so then when I went over here and I wrote this, kind of as just how I know I have to start, I would be doing that next. And this one's not going to be pretty. It's going to be like a weird number, but that's okay as long as I subtract right. So 10 squared is 100, 7 squared is 49. So if I take 49 from 100, I get 51. So y is going to equal the square root of 51, technically plus or minus because of algebra. But in our trig problem for today, because I'm there, I know that's going to be the one I have to use. I have to use negative root 51 to build these answers. I'm going to tell you another thing, or we're going to think about another thing to help us check that. Okay? Because I think out of all the things we might do wrong on a problem like that, this is the biggest thing, is forgetting about extra negatives you've got to bring in. All right, so cosine is 7/10, secant is 10/7. We don't miss those because they're like free points, and so we just pick them up. Cosine is 7/10, they told me. Secant, I know is the reciprocal. I flip that thing over. I'm cool. Sine. Sine is y over r. And I might write up here just to remind myself that y is going to be negative root 51. So this is going to be negative root 51 over 10, which is hideous, but I love it, and I'm going to write it. And then once again, I just can't help but let that negative float to the top. I'll flip it and I'll leave the negative up top. So yeah, I know it's disturbing. It looks like I now made the 10 negative. I really didn't. I just, like I said, let it float. 10 over negative 51. 10 over negative 51 is the same as negative 10 over positive root 51. This is just a prettier version mathematically. Or, you know, we could do that too as another variation. Tangent, negative root 51 over 7. So cotangent, flip that bad boy over. Like I said, I like the negative up top. Okay, how are we on that? There's a reason we're doing this kind of last, because it is probably, you know, it's got the most little pieces you got to worry about. X, Y, figuring out R, and doing it, but from a different perspective, and then having to think about the negatives and all of that. It's a lot of little information to deal with. A last thing you can do to sort of double check at least the positive, negative parts of your answer is to go back to ASTC. If you remember, ASTC told me which functions were positive in the quadrants. So in this problem, if we're in quadrant 4, the C quadrant, that means cosine and secant, its friend, are positive. And everybody else has to be negative. So if I look over at my answers and I make sure that that is what I've got, cosine and secant are my positives. Everybody else is negative. You're going to have, unless they're all positive, which you're in quadrant 1, you're always going to have one pair that's positive, and everybody else is going to be negative. If you're in quadrant 2, it's the sine pair, sine cosecant. If you're in quadrant 3, it's the tangent pair. If you're in quadrant 4, it's the cosine pair. Quadrant 1, everybody's positive, nothing to worry about with negatives. So ASTC is a good double check for, do I have my negatives and positives where they should be? I'm in quadrant 4, that's cosine positive quadrant. Cosine guys are positive, cosine and his neighbor secant. Everybody else goes negative. Okay. Some students will just say, you know what, I'm just going to think about that at the end. I'm not going to worry, I'll do all the arithmetic, I'll get my number, and then I'll put the signs on at the end. That's not a bad technique, but sometimes you forget. Like you're so happy that you're done. You're like, I wrote all these answers. You forget to go, oh wait, now who's positive? So drawing the picture right away, writing this ordered pair right away, sort of trying to emphasize right away, remembering I need some negatives probably in here is a good strategy. Okay. One more to do. Let's do, they're all a little tricky, but let's do number 12. I'm going to grab number 12 here. This is probably the trickiest type. Okay. Couple things. First of all, when you look at number 12, you might think, well, there's no ratio. Well, that's easy to fix. anything that doesn't look like a ratio, I just put over 1. So root 3 is the same as root 3 over 1. And this is supposed to be a tangent. So that's a y-x combo that I can use. I feel like my orienting is all off. Let me redo that real quick because it's just continuing to bother me. All right. So tangent is root 3 or root 3 over 1. Cotangent is then the reciprocal, which is 1 over root 3. These are kind of familiar. This is actually a special angle, but they don't care what angle it is. We just want the ratios. But this is actually going to be one of our special angles. All right. When I write this ordered pair, 1 for x, root 3 for y, this is the tricky part, they actually both have to be negative. When I put them together in the tangent in quadrant 3, that negative over a negative made a positive. But y and x are both negative. So when I write my sine and my cosine, I'm going to have negative root 3 over my r and negative 1 over my r. And then I'll flip those to get my cosecant and my secant. Once again, ASTC, if I'm in quadrant 3, my tangent family is my positives, so everybody else is going to be a negative. So we need to remember that the XY combination I build I pull out of my ratio for my ordered pair has to be negative. So here we go. Negative, so this is x squared plus y squared equals r squared. Negative 1 squared is 1. Negative root 3 squared is 3. So r squared is 4. So r is 2. Oh yeah, those are our friends. These are some friends we have. These are all the ratios that go with a special angle. Okay. It's a slightly different ordered pair for that angle. But all angles are going to have a bunch of different ordered pairs that would be good for it. We've used the special ordered pairs that are on the special circle, that are where the points are 1 unit away from the origin. But there's bunches of circles with bunches of ordered pairs. So any point along this would be an ordered pair that would go with this angle. And all those different ordered pairs would still give us all these same ratios. That's the hardest kind of one of these X, Y, R. Take one function, find the other 5. When you get a tangent out of quadrant 3, and you have to remember, even though this answer is positive, the X and the Y that built it is going to have to be negative. There's a couple extra problems you can do in here for practice, and I'll put the answers in. We're going to have something else we're going to do for practice as well. So we'll have plenty of things to practice. I like to, when I make note packets, I often make them a lot bigger than they need to be. Okay. That's the last most difficult problem you're going to do. The only other thing we have to talk about is a couple more questions that involve using ASTC. Okay. And this is kind of backwards a little bit. We probably should have done a little bit more of this before we started to get into all kinds of details of XYR, but that's okay. So let's flip back to this page. These are all just different variations of thinking about what's positive and what's negative in terms of trig functions in the different quadrants. These are also some good exercises for helping us remember our XYR definition. So I guess we had to talk a little bit about XYRs before we could do problems like this. Okay. But ultimately, the idea here, even with these, and you're like, what the heck? We're not trying to figure out values. We're just figuring out, or just talking about if the value would be positive or negative. I think this is supposed to help us when we actually go through a bunch of XYR problems, that we're just always very, very, very comfortable with what should be positive, what should be negative. This can help us with our units. Our special ordered pairs on the unit circle, once again, can help us with whichever function we're trying to figure out, what quadrant we're in, whether it's going to be positive or negative. So here's the idea. Question number 1 says, we're in quadrant 2, and what we're looking at is y over r. Now, the way I would think about this problem is this. Y over r is a sign question. Y over r is sine. Okay, we know sine is y over r, and cosine is x over r, and tangent is y over x. We're going to learn that just like we know, or should know, SOHCAHTOA. So then, if I realize I'm talking about a sine ratio, and I'm in quadrant 2, sines, that would be a positive ratio for problem number 1. That's all we're trying to figure out. Based on the ratio they gave me, based on the quadrant they gave me, are we talking about something that's positive, or are we talking about something that's negative? If we built this ratio, if we put a y number over an r number from a quadrant 2 ordered pair, would that fraction be a positive or a negative number? Okay, because, so here's why I'm saying this would be positive. If I'm in quadrant 2, I know my x is negative and my y is positive, right? So y is positive, and r is always positive, so it's going to be positive.
So if one negative, would they be negative?
Correct.
If it's 2 negatives, would be positive?
Correct. But and so almost like a shortcut of what all that you just said, but sorry, is because of how each of these are created, Like if I'm in quadrant 3, X and Y are both negative. In quadrant 3, I call that the tangent quadrant because that's the quadrant where tangents are positive. Because when I take and I make a tangent out of an ordered pair from quadrant 3, I put a negative Y over a negative X that comes out positive. Okay. So, question 2. I'm looking at a cosine, X over R. I'm still looking in quadrant 2. So if I'm doing a cosine and I'm looking at a quadrant 2 angle, is my cosine going to be negative or positive? It's going to be negative, right?
Can you explain that?
So, couple of things. If I'm in quadrant 2, if I draw another picture, and I'm like, okay, I'm over here in quadrant 2. In quadrant 2, X is negative and Y is positive. If I'm putting the X, which is negative, over R, that is positive, a negative over a positive has to make a negative. It's actually interesting. You guys, it's usually like this. You can do it, like if I give you the ordered pair, you're like, yep, and you'll put it all together. But if I think, okay, but if I tell you sort of like in general what's going to happen, it's a little harder sometimes to kind of think about it in more a general term than specific. So let's keep going though. Quadrant 3, Y over R. Quadrant 3, Y over R would be negative, right? It's a sine, and it would be negative. Okay. This part is good for practicing recognizing the ratio. Based on the quadrant you're in, you can figure out this should be negative by the fact that the Y value is negative in the ordered pair in quadrant 3, or you're in quadrant 3, that's the tangent quadrant. That means tangents and cotangents are positive. Everybody else is negative. So this is the cosine again. And we're in quadrant 3. Think about your ordered pair. X over R, negative. See if you can try those last 4. So 3, no, all 4 of them are going to ask about quadrant 4 actually. I definitely think I would rearrange some of this stuff. I've got some stuff in kind of a weird order, but we're getting through it. And then we're going to do one more kind of problem. Okay. So, you might like the ASTC. You might not. You might prefer, bless you, kind of doing this in each quadrant. Okay. You know, sort of marking, reminding yourself, okay, if I'm in a certain quadrant, how or the ordered pairs work. If you remember that R is always positive, no matter what, then if we're in quadrant 4, this guy right here, I'm doing a cosine, and he's positive because the x is positive in quadrant 4. When I'm doing a sine in quadrant 4, the y is negative, so the sine ends up being negative. Number 7 is the tangent. Positive or negative in quadrant 4? Negative. Why? When you put y over x, you put 1 negative over 1 positive. X over y. Well, that's the cotangent. Positive or negative? That's still negative, yeah. You flip a negative ratio over and it's still negative. Okay. Last thing. We're going to reverse it. In the problems above, I gave you a particular quadrant, and you told me whether certain functions were positive or negative. So like if we're in quadrant 2, we were looking at y over r, so quadrant 2 sines were positive. Quadrant 4 sines were negative. Quadrant 3 sines were negative. Quadrant 4 cosines positive. We looked at quadrants and functions. Now we're going to go backwards. I'm going to tell you some things about functions, and our job is to figure out the quadrants, or quadrant, because there might only be one, that match these conditions. Okay? So we're working backwards now. So let's read what we are given and see, these are our clues. So clue number 1 says sine of alpha is greater than 0. So sine has to be positive. Now, I like to kind of think about these questions and sort of rule things out. So if I'm talking about the 4 quadrants, and I have to be in a quadrant where sine is positive, quadrant 1 would work because everybody's positive in quadrant 1. Quadrant 2 would work because quadrant 2 says sines are positive, and another way to think about that is the y is positive. So that's what makes the sine positive. Quadrants 3 and 4, no bueno. They have negative y's, so they would have negative sines. At the same time, in addition to having my sine positive, I want the cosine to be negative. All right, so let's look at my diagram. I'm only down to 2 quadrants because of my first restriction is positive sine. If I also have to meet the criteria of negative cosines, well, 1 and 2 have positive sines. 2 has negative cosines. 3 has negative cosines, but we've already thrown it out because it doesn't have positive sines. Quadrant 1, everybody's positive. So cosine negative, I got to cross this guy out. The only matching quadrant for problem 9 that maps both those criteria is quadrant 2. Yeah? No? Sort of? You've got 4 quadrants, and you've got to figure out which ones match the criteria, but it has to match all the criteria. So the more criteria I have, the more restrictions I have, the less answers I'm probably going to have. All right, so let's talk about this second one. That's just a beta. It's a B. All right, ASTC up on the board. First thing it says, cosine beta greater than 0. Greater than 0 means positive. So where can I be and have a positive cosine? Quadrant, problem 1 and 4. Okay, so 1 is good and 4 is good because they have positive x's, and x's are what controls the cosine. So not this guy, not this guy. All right. What else do I need?
So it has to have a positive x, right?
Has to have a positive x to have a positive cosine. Yes. Yeah. See, this actually is a really good exercise. It seems kind of dumb, but it actually helps us really to learn the signs better. S-I-G-N-S. All right. So positive x's make positive cosines. Positive tangents. Where can I get positive tangents? 1 and 3. But I had to cross 3 out because 3 didn't have a positive cosine. So positive tangent plus positive cosine only quadrant 1. All right, let's keep going. I don't remember who made these notes with all these wonky Greek letters. I don't even remember what Greek letter that is. So it's some angle. Tangent of some angle, positive. All right, so I'm going to make an ASTC for this guy. Positive tangents. Where am I? Alexis said 1 and 3. Alexis is right. Alexis said 1 and 3. If we're positive, everybody's positive in quadrant 1. Tangents are positive in quadrant 3, so I'll throw those guys out. What about positive cotangents? Well, cotangents do what tangents do. So cotangents and tangents, positive in the same quadrant. So actually, problem number 11 has 2 answers, 1 and 3. Since the 2 functions they asked me to think about were kind of are related as reciprocals, wherever the tangent is positive, the cotangent is going to be positive as well. So you've got 3 more of those you can try. And this last set of problems, I think these are kind of dumb, but once again, we're sort of floating back to degrees here and thinking about quadrants with degrees specifically. The question is just positive or negative. I guess this actually kind of is a nice way to finish because it sort of takes us back to where we started. So 74 degrees being in quadrant 1. Well, if I'm in quadrant 1, Everybody's positive. Sine, cosine, tangent, all positive. So that's how you're supposed to be thinking through 16 and 17 and 18. Is you're supposed to be identifying the quadrant, and then based on what quadrant you're landing in are your functions, sine, cosine, tangent, positive or negative. So, lots to think about. That's going to be an